Hello, pre-calculus students, and welcome to the lesson on logarithms, and particularly logarithmic functions. And if you've seen this before in Algebra 2 or in some other course, it should be review for you. If you haven't seen it before, it is initially somewhat weird. But the main idea here is that exponential and logarithmic forms are just two different ways of writing the same mathematical expression. And just a little bit of motivation here. If I gave you a question like solve for x, and I said that 3 to the x equals 15. Okay? This is somewhat of a difficult problem to solve algebraically because the exponent is a variable. Okay? And up to now, what we've been doing is just solving this graphically, which will work, but it sometimes can be tedious and it can be more work than what we need to. And more importantly, it is essential that we develop these concepts beyond just relying on a calculator to solve them for us. Okay. So with this type of problem in mind, let's get going here and look at the definition of a logarithm. And the definition is a little bit unusual. It says, if b to the y equals x, then log b of x equals y. In other words, this is saying that this is the exponent. The b here, this is the base. Okay. And x is the base raised to the exponent. Okay. And it's really, again, it's just the exact same concept, but it's written a different way. And so let's look at some of our examples here. So if I had a problem in exponential form, 2 to the thirds, you can do this in your calculator. This is going to be 8. Okay. And if you wanted to write this in logarithmic form, well, we're going to need to write log. Okay. The base here is 2. Remember, b here is the base. And then 8 goes into these parentheses. Okay, so this is the base to the exponent, and the exponent is what it's equal to. So this part right here, this is pronounced, let me write it over here, log base 2 of 8. Okay. In other words, it's saying that 2 raised to what power is equal to 8? And the answer is 3. So let's try a couple more. The square root of 3, this is really 3 to the 1/2. And so what we can do here is write this in logarithms. Log base 3 here of the square root of 3 is equal to the exponent, which is 1/2. 4 to the 0 is 1, so we write this as log. Base is 4. Remember, inside the parentheses here is base to the exponent, so this is 4 to the 0, which is 1. And this is equal to the actual exponent out here, which is 0. And finally, 7 to the first is, of course, 7. So we write log base 7 of 7 is equal to 1. And these two scenarios here, these are some interesting cases that we're going to revisit later on when we deal with properties of logs. But you can sort of see that the log of 1 is always 0. Doesn't matter what the base is. And whenever the base and the expression in the parentheses are the same, the answer is going to be 1, because you're really just saying something to the first power is equal to itself. So 7 to the first power is equal to 7. Now, if you look at a conventional graphing calculator, you'll see some special cases. What you see here is the log button, And when you see log here without a base, when you type log, this is a log without a base. This is assumed to be log base 10. So log base, this is doing log base 10 of 100. Okay. And then e is considered a natural number, so the natural log is really log base e. So natural log of e is 1 because it's log base e. So your calculator comes with logs of two different bases. Log base 10, this is also called the common log, and then natural log, which is log base e. And we just make those two common cases because they're used very, very frequently. Okay. So there you have it, just kind of a very brief introduction here to logarithms. The main idea that you should take away from here is that logarithms and exponents are really just two different ways of writing the same thing. And whenever you have a statement as in logarithms, you can convert it to exponential form and vice versa. So I'm going to end this video here. I'm going to continue on the next one where we actually try to solve some logarithms.